This is second video of acid, base and salt. Understanding the chemical properties of acids and bases. Acids and bases in the laboratory. Activity 2.1. Collect the following solution from the science laboratory: hydrochloric acid, sulfuric acid, nitric acid, acetic acid, sodium hydroxide, calcium hydroxide, potassium hydroxide, magnesium hydroxide and ammonium hydroxide. Put a drop of each of the above solution on a watch glass one by one and test with a drop of indicator shown in table 2.1. What change in color did you observe with red litmus, blue litmus, phenolphthalein, methyl orange solution? For each of the solution taken, tabulate your observation in like this table 2.1. We have these acids and bases, and we have to put put a drop of each of the following solution on watch glass. Watch glass is a watch glass made of glass like this. In laboratory you can see these type of glass made of thick glass. Here we put 1-2 drop of acid and bases one by one, and then test it by like with dropper. This is structure of dropper. With dropper you put 1-2 drop of acid, each of the acids and bases dropwise, and we see what happened to that acid and base with when we touch the litmus paper, blue litmus paper, red litmus paper, or with phenolphthalein or methyl orange. What will happen? So we have to tabulate it like sample solution: red litmus solution, blue litmus solution, phenolphthalein solution and methyl orange solution. So like sample solution with HCl, as it is acid, so what HCl will do when with blue litmus, HCl solution shows blue litmus change to red in color because it is acidic solution. As you know, acidic solution changes blue litmus to red. So blue litmus will change into red. But what happened to red litmus solution? It does not show any change, so no change is there. And what happened with the phenolphthalein? Phenolphthalein have formula C20H14O4. Phenolphthalein, with phenolphthalein it is colorless. Other acid solution we had taken that sulfuric acid. With sulfuric acid, as it is acidic solution, so it will change blue litmus to red. Blue litmus change to red in color, and phenolphthalein shows colorless, and with red litmus again no change. HNO3 is acidic. How we know it is acidic? Because it changed blue litmus to red. So it is acidic solution. Phenolphthalein is colorless, and with red litmus it has no change. Acetic acid, with acetic acid, how we know that is acetic acid is acidic in nature? Because it changed blue litmus to red, and red litmus has no change, and phenolphthalein solution is colorless. Now we have bases like NOH. NOH, how we know that it is base? Because it changed red litmus to blue. Now red litmus is changed into blue in color. So it is basic solution. It is NOH, and blue litmus have no change. And phenolphthalein, which is phenolphthalein change in pink color, and phenolphthalein color change in pink. And calcium hydroxide, with calcium hydroxide is also basic solution. So it will change red litmus into blue, and with blue litmus it has no change, and with phenolphthalein its color change to pink. With KOH solution, with red litmus it is blue as it is basic. So red litmus change into blue, and red litmus solution changing into blue solution, and blue litmus has no change, either is in litmus paper or it is in solution form, it has no change. And phenolphthalein have got pink color. With magnesium hydroxide it is basic, so it will change red litmus solution into blue, and blue litmus solution has no change, and phenolphthalein has got pink color. And with ammonium hydroxide, red litmus will change to blue. With blue litmus it has no change, and phenolphthalein have got pink in color. So our this table is completed. These indicators tell us whether a substance is acidic or basic by change in color. There are some substances whose order changes in acidic or basic media. These are called olfactory indicator. Olfactory indicator. Let us try out some of these indicators. By changing order also we can observe whether it is acid or base. There are some activity. Which of these, vanilla, onion and clove, can be used as olfactory indicator? As vanilla has its own essence, onion has its own essence, and clove has its own essence. So we can use as an indicator on the basis of your observation. Let us do some more activity to understand these chemical properties of acid and bases. How do acid and bases react with metal? Now how acid and bases react with metal. Activity 2.3. Caution. This activity needs the teacher's assistance. Let us apparatus as shown in the figure 2.1. We have to set these apparatus in this way. Take about 5 ml of dilute sulfuric acid in a test tube and add a few pieces of zinc granule to it. In this test tube we have to set up like this. This is a stand. In this stand we just clamp the test tube with the help of this cord and this delivery tube, and this is soap solution in tub. So in this test tube we have sulfuric acid, dilute sulfuric acid solution, and here we put zinc granule in this test tube. So few pieces of zinc granule. What do you observe on the surface of zinc granule? Pass the gas being evolved through the soap solution. Why are bubble formed in the soap solution? Take a burning candle near the gas filled bubble. What do you observe? Repeat this activity with some more acid like HCl and HNO3 and acetic acid. Are the observation in all the cases the same or different? So we just set up this like this, and in this test tube we have dilute sulfuric acid solution, and we put zinc granule in this. So from What do you observe on the surface of zinc granule? From zinc granule, it reacts with sulfuric acid and hydrogen gas evolve. So this hydrogen gas come out from this pipe which is called delivery tube, and here we put a soap solution, and this hydrogen gas come out with burn soap bubble filled with hydrogen. This soap bubble come out filled with hydrogen gas. This is soap solution, and the hydrogen gas evolve because of this reaction of sulfuric acid with zinc. So hydrogen gas evolved soap bubble filled with hydrogen. In this soap bubble we have hydrogen gas. How we test this hydrogen gas? When we put burning candle near of it, then burning of hydrogen gas with pop sound. Hydrogen gas burn with pop sound. So we know that it is hydrogen gas. This is a set of reaction of zinc granule with dilute sulfuric acid and testing hydrogen gas by burning. By burning we can test the hydrogen gas. This is the reaction zinc solid in the form of solid, zinc solid plus sulfuric acid which is in the form of aqueous solution. Hydrogen gas evolve, zinc displaces this hydrogen and form zinc sulfate ZnSO4 in aqueous form, and hydrogen in the gas form evolve. It is in the gas form, so it come out. Hydrogen gas evolve, zinc sulfate form. Note that the metal in the above reaction displaces hydrogen atom. Metal in this reaction, metal displaces this hydrogen atom. Zinc, this metal zinc displaces hydrogen atom from sulfuric acid, and hydrogen gas evolve and zinc sulfate is formed. Note that the metal in the above reaction displaces hydrogen atom from the acid as hydrogen gas and form a compound called a salt. This is acid base reaction. So acid plus metal is equal to salt plus hydrogen gas. Acid with this is not acid base reaction, this is acid with metal reaction. Acid with metal forms salt and hydrogen gas. Note that the metal in the above reaction displaces hydrogen atom from the acid and hydrogen gas and form a compound called a salt. Thus, the reaction of a metal with an acid can be summarized as acid plus metal is equal to salt plus hydrogen. Acid plus metal is equal to salt plus hydrogen. Can you now write the equation for the reaction you have observed? Place a few pieces of granuled zinc metal in a test tube. Add 2 ml of sodium hydroxide solution and warm the content of the test tube. Repeat the test of the steps on the activity 2.3 and record your observation. Likewise, as we do with zinc and sulfuric acid, we can do with zinc granule with NaOH, sodium hydroxide. Then what happened? The reaction that take place can be written as NaOH aqueous plus zinc solid sodium zincate plus hydrogen gas evolve. Sodium hydroxide plus zinc solid we get sodium zincate and hydrogen gas evolve. You find again that hydrogen is formed in the reaction. However, such reactions are not possible with all metal. This reaction is not possible with all metal.